Okay, let's revisit the empirical rule. Remember the empirical rule? The empirical rule tells that plus or minus 1 standard deviation away from the mean, we have 68% of the data. 2 standard deviations away from the mean, we have the 95%, and 3 standard deviations away from the mean is 99.7%. What it's telling me, the empirical rule is for, normal distribution, bell-shaped symmetrical distribution. What it means is that 1 plus or minus 1 standard deviation, we are dealing with what? 68. So 0.68, 68% of the values are plus or minus 1 standard deviation. The same thing happened with 2 standard deviations, 95% or 0.95. And 3 standard deviations is most of the values. So this is 99.7 or 0.997 minus 3 standard deviation and 3 standard deviations. Okay, what does that mean? I mean, remember the example of yesterday. We had the calls, right? The mean was 12 and the standard deviation was 3. Remember that is the example from the book. Okay, what it's saying, for example, is that let's say 2 standard deviations. 2 standard deviations, 2 times 3, the standard deviation is 3. So plus or minus 6 from the mean, we have 95% of the values. So it means that if the mean is 12 plus or minus 6, from 6 to 18. Why? Because 2 times 3 is equal to 6. So 12 plus 6 is 18. 12 minus 6 is 6. Okay? The empirical rule tells me that this is 0.95, or that 95% of all the calls are between 6 minutes and 18 minutes. That is basically what the empirical rule is about. Okay? Okay? Basically. So that's one of the problems. Another thing that the book tells you in normal distribution is how to estimate the binomial distribution using what? The normal distribution. So the estimation of a binomial using the normal distribution. Okay? Remember that we did this in the previous chapter using the Poisson distribution. We estimate the binomial distribution using the Poisson distribution. Okay? Now we are going to use the normal distribution to estimate the binomial distribution. How can you do that? I mean, remember, a binomial distribution is a discrete probability distribution, and the normal distribution is a continuous probability distribution. So if I want to estimate using the normal, what is the value that x is equal to 4? Okay, and if I use the normal distribution, of course, remember, for any continuous distribution, the probability that x is equal to a particular number is equal to what? To 0. So how am I going then to estimate a continuous probability distribution using a discrete probability distribution using a continuous probability distribution if the probability that a value is equal to a particular number is equal to 0? Okay? In that case, and for this case, we have to use what is called the continuity correction factor. So I'm going to have from 3.5 to 4.5, okay? And then I'm going to estimate using the normal distribution, the binomial distribution. But using this, so the 0.5 that is going up and down is what is called the continuity correction factor. That is 0.5. Always 0.5. So if in the binomial distribution I want to know what is the probability that x is equal to 4, for the normal distribution I'm going to use this, the probability that 3.5 less or equal than x less or equal than 4.5. So this is for the normal distribution, and for the binomial distribution I want to know what is the value of the probability that x is equal to 4. Okay? Basically. So, and that is for the equal. So, for the, just to give you some hints about this, and this might be in the test. If I want to know what is the probability that x is equal to 4 in the binomial distribution, what do I have to do in the normal distribution? I have to find out what is the probability that 3.5 less or equal than x less or equal than 4.5. You see? Because we have to use this continuity correction factor that is plus or minus 0.5. What if in the binomial I want to know what is probability that x is less than 4? Less than 4, so the 4 is not included. So for the normal distribution, I have to use what is the probability that x is less or equal than 3.5. Okay? What if the probability that x is less or equal than 4? Then I have to, in the normal distribution, know what is the probability that x is less or equal than what? I mean, the 4 has to be included, 4.5. So in every time that I try to estimate the binomial distribution using the normal distribution, we have to use the continuity correction factor that is 0.5. It's the same thing happened with the greater. What is the probability that x is greater than 4? It's exactly the probability that x is greater or equal than 4.5. Why? Because the 4 is not included. Or what is the probability that x is greater or equal than 4? We have to say in the normal distribution the probability that x is greater or equal, the 4 has to be included, so it's 3.5. You see? Basically, that's what this estimation using the normal distribution. Okay. Now, guys, we can have the TI-84 instead of the tables in your book. How are you going to do that? Okay. Let's say, I'm going to break this, and let's do both the table and the calculator. Okay, let's say that I want to know what is the probability that in the standard normal distribution minus 1.33. What is this probability? What is this probability? Go to the tables. In the test, you will have the tables with you. Okay? You don't have the book, but you have the table. Okay, I want to know what is the probability that is less than 1.33. Negative 1.33, you go to the table, and that probability is equal to what? 0.0918. So this probability is equal to 0.0918. Okay. for the TI-84 or 83, anyway, you have to go to second bars or distributions, okay? Go to normal CDF. Why? Because we have to use the cumulative distribution function because we have to, look for probabilities. That is the number 2. Go down, okay? Hit enter, and the system is going to ask you the parameters, okay? The calculator. What are the parameters? The parameters are the lower limit, comma, the upper limit. Okay? What is the lower limit? Guys, the standard distribution or standard normal distribution or any normal distributions goes from negative minus infinite to positive infinite. Okay? So I want to know what is the area below negative 1.33. So I have to give it the lower limit. But what is the lower limit? What is the minus infinite? Minus infinite, sorry. Minus infinite. What is the minus infinite? How do I enter minus infinite in my calculator? I can say, well, the lower limit can be minus 10 to the power of 10 to the power 299. Okay? We can do that. However, it's exactly the same. The calculator gives you the same results if you enter minus 20. Minus 20 or 20 positive is the infinite or the negative infinite. Or you can say minus 50. Use any number. Don't worry about entering minus 10 to the power of 99 or whatever power it is. Just hit minus 20. So minus 20, comma, negative 1.33. So let's see what we have. Minus 20, comma, negative 1.33. Enter, and it's going to give me 0.091759 and so on and so on. So it's exactly. Amen.
What if you put in there negative 10?
I don't know. Let me check it. Probably it's going to give you the same results. Probably. Negative 10, comma, negative 1.33. Enter. It's a slight different. Gives me 0.091759. No, it's exactly the same. It's exactly the same. It's exactly the same. So, you choose a big number. It can be minus 20 or minus 10, probably. It doesn't matter. So give the why? Because remember, the majority, 99%, 99.7%, according to the empirical rules. So minus 3 plus 3. So this is what? We just covered that, 0.997. So what is in the tails over here is so small. It's 0.003 or 0.0015. This is what is over here. So this is the negative 3. So the negative 10 is like over here. So it should be very, very small, especially when we round to the 4 decimal positions, like the tables in the book. Okay? Yeah, man. But instead of putting the negative infinite, you can have negative 20 to be more safe. Or the positive infinite, you put just positive 20. in your calculator and gives you exactly the same response. Okay? What if I want to know, I'm going to erase this. What is the area to the right of positive 1.33? What is this area over here? What is that? You can do many ways to do that using the tables. Is 1 minus what is in the table, okay? But if you see and you know that the standard normal distribution is a symmetrical distribution, which is a mirror, you should know that this is equal to what? What? I mean, isn't it? It's 0.0918. It's exactly this one. Why? Because we are dealing with a symmetrical distribution. And if you want to verify that in your tables, you can do that. Now, how am I going to do this? How am I going to do this? Well, go to the TI-81 bar, the second bars or distributions, go to the normal CDF, hit enter, and hit enter, and you have to give it the lower number. What is the lower number? 1.33 positive, 1.33 comma, and plus infinite, right? Because I want to go through infinite. But again, if you just enter 20, it's going to give you 0.091759, exactly the same results. Okay? What if you want to know what is the probability between 0.3 and 0.7 in a normal distribution? Okay? Instead of going to the table for 0.7 and, you know, there are many ways. But if you want to do it using the TI-84, just hit second bars, normal distribution, and you hit 0.3, comma, 0.7, and enter, and it's going to give you that this probability is 0.1405. Okay? So you can use the tables, or you can use your TI-84. If you don't have a TI-84, you will have tables in the in the test. Is what? 0.3, 0.7. Yeah, 0.3, 0.7. I mean, it can be any number. It can be 1 and 1.3, or 0.5 and 2.33, or 0, or -1 and +1, and so on. Okay? So you can do that using the TI-84. If you want. So there are options. Okay, any questions?
Is that only used for like the standard probabilities or the normal?
Standard normal distribution. This is the Z. Standard normal distribution. This is the Z, where the mean is equal to 0 and sigma is equal to 1. Okay?
What if it's in the normal?
In any normal distribution, well, I didn't want to show you that, but if it's a normal distribution, any normal distribution, you can do it as well with the TI-84, okay? And you use the normal CDF, and you have to enter the low limit, the upper limit, the mu, and the sigma. Any standard, any distribution, any normal distribution can be used using your TI-84. Okay, you have to enter another 2 parameters. If you don't enter these parameters, the calculator assumes that mu is equal to 0 and sigma is equal to 1. Okay? But if you enter those parameters, so it's easier. It's much easier. So you just enter the mean and the sigma for the normal distribution, any normal distribution, and voila, you have the probability solution. But remember, we have to use the CDF. Don't use the PDF. The CDF, the cumulative distribution function. Okay. Let's cover now the exponential distribution. We're done with the normal distribution. Let's do exponential distribution. Exponential. The exponential distribution goes from 0 to infinite. Not from negative infinite, like in the standard, like in the normal distribution. It goes from 0 to infinite. And it has a shape more or less like this. Okay. What is the area over here? What is the area? How much is this? What is the area? Guys, in any continuous distribution, the area of the function has to be equal to 1. Okay? Now, there are some similarities with the exponential and the Poisson distribution. Remember, the Poisson distribution measures the number of customers that arrive every time period, right? The exponential distribution measures the time between arrivals, the mean time between arrivals. So there is extremely close relationship between the Poisson distribution that measures the number of customers or number of people that arrive every time period, and the exponential distribution that measures the time between arrivals. Okay, so mu is the mean time between arrivals. And if, for example, let's say that in the Poisson distribution we have 4 customers per hour. What would be the mu? If lambda is equal to 4 customers per hour, okay, my mu would be 1/4 hours between customers. Or if you want to, be very careful in the if you use hours, you use hours everywhere, or if you use minutes, it's minutes everywhere. So 4 customers per 60 divided by 60 minutes. No, that's lambda, okay? The mu is 1/lambda, so it's going to be 60 divided by 4, it's going to be 15 minutes. Okay? So the mean is the opposite or the inverse of the lambda. If I have a lambda of 4 customers every 60 minutes, what would be the mu? 15 minutes. Okay, so every 15 minutes we will have a customer arriving to the store. Anyways, we have the mean. And again, this distribution also is very used in QM theory to, make a simulation how the queues will behave in a service department. Okay. And for the exponential distribution, the probability that x is less or equal than a particular number is equal to 1 minus e. Remember, what is e? It's just a constant. E to the power of minus a divided by b. That is a formula that has to be in your cheat sheet. Why? Because it measures what is the probability that x is less or equal than whatever number it is, a. is 1 minus e to the power of minus a divided by u. Now, what is the probability that x is greater or equal than a? Okay, it has to be 1 minus this, right? And 1 minus that is equal to e to the power of minus a divided by u. So, it's 1 minus 1 minus e to the power of minus a divided by u. This 1 goes to this 1. This minus goes to positive e. So it's a positive e to the power of a to the power. Okay?
I need you to go over there one more time.
Okay. Since I want to know what is the probability that x is greater or equal than a, so I'm looking for the right side. Okay? And since the whole stuff is equal to 1, I'm looking for this one, right? And I have that this one is equal to this one. So in order to find this one, I have to have what? The whole thing is equal to 1, so it's 1 minus this area over here, right? So it's 1 minus e to the power of minus a divided by mu. Okay? So this positive 1 goes to this negative 1. This negative becomes a positive over here, so and that is why the response is this one. That's it. But be very careful in using the same units. If I tell you 4 customers per hour, either you use 1/4 hours between arrivals, or you use 15 minutes. But you cannot use hours and minutes at the same time. Mu is equal to mu sigma squared. The variance is equal to mu. Okay, if I tell you what is the mean is the mean. What is the standard deviation? This is the variance, so the standard deviation has to be the square root of the mean. Do we have that in the theory report? No. Do we have that in the tables? No. Guys, we have to do it using the formulas. That's it. There is no other way. There is no way that you can have this in your theory report. There is no way. I mean, there are no tables for this one. So you have to use the formulas to get the probability. Now, what is the probability that x is equal to 7? What is that probability? I don't have to give you any more. What is the probability that x is equal to 7 in the exponential distribution? 0. There are no areas. Remember, in continuous distributions, the probabilities are measured in areas. And there is no area when we have the probability of x is equal to 7. No area, so the probability is equal to 0. I don't have to give you anything else. You don't have to know what is mu. The probability always is equal to 0 when you have a particular equal to a particular number. It doesn't matter what the number is. Okay? And that's it.
They usually give you the lambda.
They give you the mu. Or the mu or the lambda. But probably the lambda is for the Poisson distribution. But if they give you the lambda and you need to use exponential distribution, you have to convert it. The mu.
So, like what if I have to convert the lambda to the mu
Yeah.
in the test?
Yeah. Could be. I haven't done the test. Okay? But the mean is the time between arrival. Remember, this is continuous probability distribution, and continuous probability distribution measure continuous variables, and time is one continuous variable. The number of customers, that is the Poisson distribution, measure a discrete probability distribution. We cannot have 3.37 customers arriving in an hour. I mean, either have 3 customers or 4 customers or 5 or 6 or whatever. exponential distribution, the mean is equal to time, or whatever continuous variable it is. Let's do a problem, so you know what it's all about. And guys, what is the probability that is between A and B? Okay, you have to use the probability of B minus the probability of A. Okay, so is the probability that X is less or equal than B minus the probability of X is less or equal than A. Okay, exactly what we had when we use the normal distribution. When we have an interval, we first need to calculate the probability that X is less or equal than B. Okay, that is equal to what? 1 minus e to the power of minus B divided by mu. Okay, minus 1 minus e to the power of minus A divided by mu. You see? So you have to do this kind of thing. So if either is less, greater, or in an interval. Less or equal, greater or equal, or in an interval. Okay, let's do one problem in your book. I don't have any. I mean, that's pretty easy. The book also tells you about the density function. You don't need the density function in order to find out what is the probability. In order to find the probability, you just need the probability that X is less or equal than a variable is given by the formula 1 minus e to the power of minus A divided by B. Okay. Okay. Let's do 622. I know it's part of the homework, but it doesn't matter. I'm going to give you 6.22. We have an exponential probability distribution with a mean equal to 7 minutes. So the mu is equal to 7 minutes. Calculate the following probabilities. A, the probability that X is greater than 12. So it's asking me, this is 12 and this is the probability. That's it. I mean, it's pretty easy. This is e to the power of minus 12 divided by 6. That's it. Get it into the calculator. And that probability, 12 divided by 7, negative e to the power. This is equal to 0.8. Okay? B, what is the probability that X is greater than 3? Okay, no. C, let's say C. C is probability that 7 less or equal than X is 7 less or equal than X less or equal than 10. What do we have to do in here? We have to what? Say 1 minus e to the power of 10 divided by 7. Remember, the 7 is the mu, and the formula tells you, so you have to go first with the highest number. Okay? Minus the lowest number. What is the area to the lowest number? Okay, so in this one, we have to know what is from 7 to 10. What is this probability? From 7 to 10. So we use first the 10, and the 10 to the left is 1 minus e to the power of 10 divided by 7, or the number divided by mu, minus the 7, 1 minus e to the power of negative, minus 7 divided by 7. Okay? Remember the negative exponent. It has to be a negative exponent.
Always.
Always. Amen. Yes. Okay, so 10 divided by 7, negative e to the power, negative plus 1, this is equal to 0.6603. Minus, let's go the other one, 1, negative e to the power, negative plus 1, minus 0.6321. Okay, so it's 0.7603 minus 0.6321. This is equal to 0.1282.
Okay, how you got the X?
The what?
How you got those X?
You just plug the numbers in your calculator.
You said 1 minus what?
1 minus E. What is E? Well, guys, I don't know how to use the TI-84 very well. You need to know how to use it.
You push second, and then the divided sign, that's the E.
Okay, there you go. In the second logarithm, natural logarithms, okay? That is the, for example, negative 1. So negative 1, negative 1, then second logarithm. Oh, no. So it's second logarithm, and then negative 1, enter, and it's going to be 0.3687, but you have to do 1 minus whatever it is, so it's going to be equal to 0.6321. Okay? So, and then again, guys, this is not a calculator 101. You need to know how to use this. You need to know how to drive your car in order to use it. Okay? So, and this is not a calculator 101. So, I feel more comfortable using this, and that's why I use this one, because that's the one that I used to it. This is the first semester that I tried to use the TI-84, so I don't know how to use it. And really, this is so powerful. I mean, you can enter the density function and make the integration from whatever to whatever, and that's it. If you can enter the function by itself, the function, you can enter the function and then integrate from 0 to 7 the function. And you can do that using this, but I don't know how to do it. I'm sorry. I will learn eventually. Okay. So basically, this is the exponential distribution.